Hey guys, so today we're going to be going over related rates, and more specifically, we're going to be going over the cone problem. So related rates in general, a lot of people don't like, but it's one of the most common setups in AP Calc. When I took the AP exam, I had to do a cone problem actually. So hopefully this helps you guys. So yeah, let's get right into it. So water is poured into an inverted cone at a rate of dVdt equals 3 cubic feet per minute. The cone has height 10 feet and radius 4 feet. How fast is the water level rising when the water is 5 feet deep? Okay, so I drew a little cone here. Not a great cone, but it's a cone. So the whole trick is you don't plug in numbers until the end, because if you plug in numbers, you're usually going to screw up somewhere. All right? So what I like to do in related rates, I like to write down what I know. We know dVdt, so we know the cone, we know the height is 10, the radius is 4, and we want to know or like unknown, what we want to find, I'll write it in pink, is dHdt. That is what we want to find. It's like this. Okay? This is what we want. dHdt, how fast is the water level rising when the water is 5 feet deep and at h equals 5. Okay, so now the first step is always geometry. The water, right? So if let's pretend the water's getting poured in. The water's getting poured in, right? Like this. Do you guys see the water's making kind of like a small cone inside of the big cone? So you use similar triangles. So this is going to be r, some r, and this is going to be some h. So using similar triangles, we know that r over h, that ratio is going to be the same as the ratio 4 over 10. So now, what do we do? Well, r equals, you can simplify this down, you're going to get r equals 2/5 h, and you'll see why we needed to do this. So this is a key move. Related rates are usually about finding a relationship, so you don't have two variables. So now, let's use the cone volume formula. They're gonna give this to you. So the volume of a cone is 1/3 pi r squared h. So do you guys see? We have two unknowns. We have an r and an h. But since we solved for r in terms of h, all we're gonna have now is two h's. So that's why we did what we did. All right. In a lot of related rates problems, you're not gonna have this type of problem. You're not gonna have to convert one variable in terms of another, but especially for these cone ones, it's super super common. So we want everything in one variable, so let's do that. So the volume is going to be 1/3 pi, and then r squared, we're just going to substitute what we got in terms of h, and then this simplifies down to, if I do it all the way out, 4 pi 75 h cubed. So now v is only in terms of h. Now, this is our important step. We have to differentiate both sides with respect to time t. Okay, so now that we have shrunk it down a little bit to give us more space, I'm going to use red for the differentiating. No, I'll use orange for the differentiating part. So we're going to take the derivative of both sides, so dv dt. Why do we take the derivative? Well, we know what dv dt is, right? dv dt is 3 cubic feet per minute. And now we're going to have to use chain rule, right? Because this is an h, and or actually no, this is more of implicit differentiation. Technically it is chain rule, but in more broad terms it's implicit differentiation. So this would become derivative ddt of 4 pi over 75 h cubed. So now we get 4 pi, oops, I can't write today, 4 pi over 75 times 3h squared dh dt using, and let me just write this in blue so you guys know, implicit differentiation. And if you guys are a little bit shaky on this, I have a video on that, on implicit differentiation. So So I'd recommend go watch that. So now we have this. And remember, we wanted to find dHdt from the start. So great, we have a dHdt in our equation. So we finally have the two rates connected. We have dVdt and dHdt. So now, and only now, we're going to plug in the values. Remember I said in the beginning, you don't plug in values from the start. You plug it in at the end. Otherwise, you're going to screw up somewhere. So dVdt equals all this. So dVdt we said was 3. I'm not going to write units right now. Let me use red. So dVdt is 3 equals 4 pi 75, 4 pi over 75 times 3. What is h? Is h 10? No. It's asking when the water is 5 feet deep. So we want h to be 5 squared times dh dt. And if we simplify this all down, right, we're going to get dh dt is going to be, let me write it up here. So dh dt equals 3 over 4 pi feet per minute. And boom, that is our answer. So we can do a quick little sanity check. Water's going in, right? The water's going into the cone. So the height should increase, and it is. It's a positive. But the biggest mistake people make is that people plug in r equals 5 or h equals 10, r equals 4, whatever, before relating r and h. So if you plug in early, you break the relationship and the whole problem collapses. So this is our final answer. dHdt is 3 over 4 pi feet per minute. Yeah, and that's really all there is to it. It's a little bit more steps than a regular related rates problem, but it's not terrible. So yeah, I hope you guys feel a little bit more comfortable with these types of questions. If you have any feedback for me, if you have any unanswered questions or any videos you guys would like to see me make next, as always, just leave them in the comments. I'll answer them all. Thank you guys so much for watching, and I'll see you guys in the next video.